Dear participants, first of all, I want to say hi from Ankara, Turkey. I'm very pleased to welcome you to this 3-day online OpenSees workshop, which is organized by the Earthquake Engineering Association of Turkey.
I also like to introduce our keynote distinguished speakers. First is Dr. Silvia Mazzoni from University of California. She has been training OpenSees users for over 20 years. I know many of you are familiar with her. She developed the first OpenSees Days workshops, which we also followed and learned a lot during these days. In the OpenSees Wiki, she wrote a lot of content as well. And as an independent consultant, she now works with engineering firms. She has an online academy for earthquake engineering, which is called Silvia's Brainery. That's a very good and fun website. I suggest you Google it and enjoy this site and get the content. She's right now also a project scientist and lecturer at UCLA, and he teaches the graduate courses on structural dynamics in the fall.
Hello, everybody. I'm very excited to be here. I love the high count of this participation and enthusiasm that is out there for OpenSees. First of all, I wanted to thank the workshop organizers. It's great to see others picking up this process of sharing your knowledge and experience, which is really what OpenSees is about. It's not just a platform for performing analysis, but it's really a resource for a community. And it's great to see the community being built. So thank you for organizing this workshop. My presentation today is going to be very much oriented towards users and developers for all the resources that are out there. I get so many questions on Facebook Messenger and here and there, questions about particular things. And I always send them back, well, have you looked at what the manual says? Have you looked at other resources? And so what I want to do today is throw everything at you so that you know that where you can go and the different resources that are available, so you can build up knowledge so that you can gain a better understanding how OpenSees works, and then you can actually contribute and ask great questions to the community. So that's my purpose today. It's very much from a user and as well as early developers. Let me see if I can go to my next slide. There it is. This is a screenshot, and it's very unfair, but I don't have data on how popular OpenSees itself is. So this is pretty much data from my own website. And what I've done is I've built, and thank you for mentioning my fun website. I've built this website online to put all these different resources together. Of course, you know, there's additional services that I offer, but I'm also bringing in all the other communities and resources and put them all into one place so that it's much easier access. So what I have here is just a screenshot from maybe a couple of days ago of people who visited my website, which has only been up for 6 months. But you can see here how it's all over the world, all the way from the corner down in New Zealand up to Canada. And it pretty much hits all corners throughout. Lots of work being done in Europe. I mean, even as far north as the United Kingdom. And of course, lots of activity in Turkey right now. So it's fun to see how people are using OpenSees everywhere. It's mainly developed everywhere, and it's being used everywhere, as previous speakers have already pointed out. It's just something that just keeps growing on its own. And so really that begs a question, and I kind of want to give my own perspective of why OpenSees. Well, because it was developed for education and community. That was really the goal in the early development is, okay, it was developed at UC Berkeley by a professor and a graduate student in saying, how can we build a community-based program where people can contribute? We no longer want this black box that not only can we not contribute to it, but we don't even know how it works. And so it was a shift in paradigm on building a software that isn't just for analyzing buildings, but it's for educating and building a community. And that was in the design of the software platform itself. And it's neat to see that that really worked. What's advantageous to it, it's free, which makes it great for students and researchers and even small offices. A lot of engineering offices in the US are big and have a lot of resources, but throughout the world, you know, I'm Italian, and so I deal a lot with Italian engineers. They're small offices, so the expense of the software itself sometimes isn't warranted. So it's great that OpenSees gives you access to being able to do high fidelity analyses without such large costs. And then, you know, the fact that it's open source, I've already mentioned it, but it's neat because again, it's not that black box that you don't know what's going on, but it comes with a caveat that you've got to look under the hood because it's continually evolving and it's got a set of core developers, but then there's graduate students and researchers that develop additional components, and this library of components such as materials and elements and even applications is growing. You really need to keep up with it every day, kind of, you know, at least when you're using it, and see why and what are the limitations and the assumptions that are made in these developments. So it's no longer a black box where you just click buttons. You have a responsibility to go under the hood, and that's what I really encourage you to do. There's a lot of resources out there. I'm really going to just show you a lot of them, but I know it's not all that is out there. So really spend the time, invest the time into seeing what's been done and what people are doing and what people are talking about. The power of OpenSees is that it's actually a lot of structural as well as geotechnical applications. I love the list of keynote speakers that you have. Professor Arduino, he's just an amazing teacher. And even that session on the geotechnical is going to benefit the geotechnical engineers. But I think almost who's really going to get the most out of it is the structural engineers, because you learn a lot about geotechnical engineering just from Professor Arduino. And same with the other presenters that you have. Selim, he's Turkish. He's one of you guys. He's awesome. He has such an amazing experience with so many different aspects of OpenSees and just analysis and behavior that I'm excited for you to have him as a keynote speaker. Make sure you ask him a lot of questions. He has great insight. And then what's great about it, it's a multi-platform. Most of us use it on Windows. Some people use it on a Mac, and but also brings in the resources of high performance computing. And I will highlight some of those. What's neat also is you can, it has multiple interpreters. You know, it's a C++ program, so the best way to do it is actually to work with the original makefile itself. Then there's the Tickle interpreter that was the original, which I'm a big fan of. Now they've done a Python interpreter, which is kind of cool. Too many commas and formatting with Python, but it's actually nice because you can bring in a lot of resources that come in with Python. And then the developers of OpenSees Pi have actually gone in and modified it so that you can now bring in other APIs. So it's ready to be brought into other interpreters as well. And that really shows you how OpenSees is growing in so many directions. You could be a structural engineer, you could be a geotechnical engineer, but you could even just be a computer scientist interested in developing the computer science aspect of it. And of course, because of that, it's a large ecosystem. There's lots of free resources out there. Some are great, some are good, but it's neat to just see the heart that people have put into doing a lot of, you know, YouTube is a great place. I love how there's some things are actually in Spanish, I've noticed. I don't know about the other languages, I don't know them, but it's kind of neat to follow it. Even people have done it, you know, language specific. There's a lot of collaboration and also a lot of, and I'll show you some highlights of, and you have Professor Dr. Petraka coming on Sunday, actual tool developments and financial people who have invested into developing tools for OpenSees. I've done my own. It's nothing as fancy as theirs, but it's kind of neat how it's a programmable user interface, which to me is the biggest strength and allows you to develop a lot of other things around it. So keep this in mind when you're working with OpenSees. I know it's people say it's a steep learning curve. I think that's more of a fear, and we think it is. It's kind of like broccoli. Broccoli is actually good. I think we need to change the rhetoric and say, hey, there's so much power into making a programmable user interface versus click button. You got to learn it, you got to do the work, but there's nothing bad about work. So I think we want to, I appreciate what we're doing in this workshop and just changing the rhetoric to saying OpenSees is not that hard to learn. You just got to dedicate your time to doing it and thinking about it and looking at all the resources. And so that's pretty much what I want to talk about today is these resources. But I want to keep in mind that OpenSees itself is a resource. It's just a tool. We spend a lot of time on it, but spend the time thinking about it. The real question isn't about what are the commands in OpenSees, but what do I want to do in modeling? How am I want to be able to model, even fire nowadays, there's OpenSees Fire, whether you want to do some 3D finite elements or you want to use line elements, whether you're doing a lot of analyses, such as, for example, an incremental dynamic analysis with a lot of different structures or different ground motions. And so we got to keep in mind that the hardest thing is coming up with the model. Then putting the language together is secondary. So I think we want to spend a bit more time as well thinking about, once we have this common language of OpenSees, let's think about how we want to build different types of models. So I wanted to put that in perspective, that there's so much, once we get the language down, there's just so much to talk about as well. The different types of, I've tried to put these resources into boxes. And so this is just a high level one, and then I'm going to go into the details of them and just give you my perspective on each one of these. The first place you start is, of course, opensees.berkeley.edu. This is the website where you download the program itself. It gives you access to the source code. It gives you access to, even the wiki. There's links to the wiki for OpenSees, and also where there's presentations of events, if there's any OpenSees days, and that's really the core of OpenSees. Of course, that's just a core that's almost small compared to how much more is going on outside of there. But still, there's a lot going on in the wiki, even though right now it's being rewritten into something a little bit more streamlined and easier to update. But that's a great place to start, is look at the wiki and the getting started manual, the command manuals, and also the developer and examples manuals. And so I'll highlight those. As somebody already pointed out, OpenSees Pi has come out. So a lot of students like Python. A lot of other courses are based on Python. And so it's nice that you can now integrate your pre-processing, because for some reason people didn't love Tickle, and I don't know why. I love Tickle myself, but people were going over to MATLAB as a pre and post processor for OpenSees, which I think it's just, I don't like discontinuities like that. So bringing in OpenSees Pi has definitely now integrated the pre and post processing into OpenSees itself, which I think is better because it minimizes the chances of making errors and introducing errors into your during the analysis and post-processing. So you know exactly what OpenSees is, and you can query, okay, OpenSees, tell me what it is that I've actually defined in my nodal coordinates. This is what I think I have, but it's always good to check. So I'm really excited about what OpenSees Pi is doing. If you're learning OpenSees, I hear that OpenSees Pi is easier to, Python itself, it's an easier language to learn. Therefore, a lot of new students are coming in. I know that you guys are going to be doing this workshop based on OpenSees Tickle and the Tickle version, because how most of us have learned it. And I want to tell those people out there that no matter whether you're taught or you receive a file in Tickle or Python, the format is the same. And the order of the commands is the same. Everything is the same, except for in Tickle, you have spaces, and in Python, you have commas. In Tickle, you don't have to put quotes around strings, and in Python you do. And then if statements are just slightly different, and in Python you have to use a tab. You have to be careful with your tabulation. And that's all there is a difference between the two languages. So if somebody gives you a script in Tickle, but you're working in Python, don't be afraid of it, because it's just a different grammar. So it's almost like Italian and Spanish. If you know one, you can understand the other. So again, it's kind of exciting to see where Python is taking it, because I think it's making it a lot more accessible to people who are afraid of OpenSees. But of course, we shouldn't be afraid of OpenSees. The other two resources that I'm highlighting here one is Google. just go in, type in OpenSees and whatever keywords you want, and you will just get a huge list of the latest, the oldest. Same with YouTube. You will see some really, really old videos from me before I had kids, who are now teenagers and adults, and you see more recent things. So there's a wide library of material out there, both just through Google and then just within YouTube itself. There's high performance computing resources in the US. There's Design Safe, so I'm going to show that to you. I'm not sure how accessible that is outside of the US, but that's a great research opportunity. And I know that many of you guys have done visiting periods in the US, and so that's definitely a resource to keep in mind. Lots of community resources. I know most of you guys through the Facebook group on OpenSees, so it's kind of fun that way. And as I've already mentioned, there's lots of external business ventures. I recommend that I get a lot of, as I said before, I get a lot of questions. Oh, how do I do this? Well, Google it. It's out there. And so spend that time initially looking at all these different resources that I'm going to give you. And what I've done is I've actually put them on my website so that they're just that much easier to access. But it's really hard for me to keep up with everything that's going on. So I've only put things that I think are interesting to me right now, which doesn't last long, I have to say. So here's my website. If you go to the resources, there's a huge pull down menu, and it's shown right here on just a lot of everything related to OpenSees. I do a lot of ground motion work, so this is going to get reformatted into being OpenSees, and then I'm trying to bring in all my other resources and knowledge that I have in there. So things may be getting moved around, but I'm trying to put everything as a one-stop shop on my website. And I'm trying to keep it colorful, but my husband said it was just too fun. So I've cooled down the graphics on my website. But that's a recommended place I recommend to go. And it's silviasbrainery.com. If you point your phone to this little picture up on the top right, it will actually take you there. That's my QR code. And I think even if you just put in silviamazzoni.com right now, it sends you to this website. So it's easy to go there, and I've put a link to everything. You'll see as you go through these pull down menus, on the bottom left is going to give you the link that it's going to go to. Oftentimes I just put it within the page itself so it's easier to navigate as you're shopping around. Here's the OpenSees webpage. It's literally the place to start. Anytime you're working with OpenSees, make sure that you're using the latest version of the binary. So right now, as of yesterday, it was at 3.2.2. That's always the first question when somebody has problems. Well, which version of OpenSees are you using? And that's limiting, and sometimes, you know, an older version may be easier to deal with than the newer versions, but make sure you're on top of it, and then you can provide feedback if there's any changes that are affecting your modeling whenever a new release is out. It's really important to communicate back to the OpenSees team. There's a lot of one-way communication, but until they receive feedback or even feature requests, it's pretty hard to improve the software itself, because then you want to minimize the branching that's going on. This is where you download. You need to register an email, and then once you have an email there, you just keep on going and make sure you download the latest version of OpenSees. Very careful, the newest versions of OpenSees include Tickle themselves, and so you don't have to install Tickle first, which used to be a problem. Now it all comes together. If you watch the YouTube video that I have on installing OpenSees, it shows you what to do, and it's become a pretty popular video because there's some little tricks that I show you that make life that much easier. There's also a Mac version, and well, this looks good. It is at 3.2.2, but the Mac version doesn't always keep up with the Windows version, or vice. No, I'm pretty sure the Windows version is always compiled fastest. The other place to go, and it's the best place that I always tell, if you have a question about a command, go to the source code. And because it's not protected, I put the link on my website, and you just click it. And so this is just a screenshot. Go to the source code, open up it's open source. So open up the elements or the examples they have and really spend a few hours once in a while just going through the source code to understand it. It's really neat. You learn not just, you can learn about C programming as well, but also just learn about how OpenSees really works. So if somebody says, well, that command does this, and then somebody, but it doesn't quite look like that's the results you're getting, again, go to the source code and then you have it right. So there's no question of what the answer is there. This is just a zoom of the GitHub, and it's kind of cool. I mean, look at this. There's 39 contributors to the GitHub, plus another 28 contributors. So that is how many people have put code into the GitHub. Then, you know, the development team, Professor Michael Scott and Frank McKenna, manage, and I think there's a couple of other individuals, manage all the different pushes and pulls within GitHub. But it's kind of exciting to see it. And you see things that were done maybe 10 days ago and 2 months ago. And then maybe if you scroll down, you'll find things that were touched 12 years ago. So there's a lot going on just within GitHub that you're not just a user anymore. When you come into OpenSees, there's no hierarchy. Everybody's working on this together. And there's no, you know, specific roles. You as a user are informing the developers. And that comes with the responsibility. But I think it's kind of cool. A fun place to go is Professor Michael Scott's blog. I have a link to it on the resources. Go on and sign up. The month of November, he actually posted one blog each day. They're great because he poses questions. He's not there to answer, oh, how do you design a beam? But it's like, or how do you analyze a beam? He's like, well, why would you use this versus, you know, why would you use a distributed plasticity element instead of a lump plasticity element? And he doesn't quite give you the answer because there isn't a straightforward answer. And he really makes you think. I mean, it makes me think. I'm subscribed to his blogs, and it's always interesting to see his perspective. And I learn something new every time. So I recommend that you guys sign up for that. And the other thing that Professor Scott is doing, and he and I are working a lot together these days on trying to bring this OpenSees community. I've been away from OpenSees for the last 10 years or so, so now I'm excited to kind of come back into the battlefield. We're just really trying to get people out there to understand what OpenSees does, and again, what's behind everything. And so he teaches nonlinear structure analysis at University of Oregon or Oregon State, somewhere up north of me. And so he's now re-recording his nonlinear analysis class, and he's putting this on YouTube. I think he loaded this up a couple of days ago, if not yesterday afternoon. So I would recommend going to his channel. I have a link to it here on my website, but then just go straight to his channel. I have links to YouTube channels just to put in one place, but then it's easier to just manage them just on YouTube itself. Subscribe to this course. I'm excited to actually learn what it is that I'm doing, because as I said at the beginning, it's not about the commands in OpenSees. It's about what you're doing and how you want to do it, because OpenSees doesn't make those decisions for you. You now have to make the decisions on the different types of solvers that you want to use. So this is a great resource, also his YouTube channel. The OpenSees Wiki, it's there. There's a lot of resources for users and developers. For the users, there's a command manual, which is great because I wrote it, of course. But this is getting transitioned into a different manual type. But even if you're using right now for the next few months or maybe a year, if you're using the Python manual, the Python manual doesn't have, OpenSees Python manual doesn't have all the figures that the Tickle version does. So I always kind of go back and forth between the two. There's a getting started manual that I wrote a long time ago. I'm not sure that the download part is consistent, but it's a great way to kind of walk you through what you're supposed to be doing and an outlining for your analyses. The examples manuals, there's 2 of them. I had developed what then they decided to call an advanced example manual. I like to think of it as an advancing, because I help you walk through a simple model to more complicated. But then there's also other just basic examples manuals that were developed just by the community. And so you can see here, very specific, you know, just a truss example, a steel frame example, different types of examples. The example manual that I wrote walks you through simple structures, elastic, all the way to fiber sections, simple cantilevers, all the way to 3D. I'm a big fan of bringing in units and variables and visualization scripts for Tickle, some analysis scripts and convergence scripts. So that's where you find all those in this examples manual as you go through and evolve from example 1 all the way to example 9. So I recommend that you go through this example. It shows you how to do all these different types of loadings as well. And remember, OpenSees, you never start your script from scratch. You always inherit something, especially as students, you know. I can always tell where a script comes from because they're always passed down from one generation of students and postdocs to the next. So, which is great. And so in the manual here, I just give some generalized scripts that then you can just carry through in whatever analysis you're doing. And, you know, there's simple examples that you can do by hand or just sourcing the file itself. So it's really straightforward and easy to do with those examples. What I've done is I've converted all those examples to OpenSees Pi, and you can download them for free from my website. I couldn't redo, even though I wrote the original examples in OpenSees Tickle, those you have to go from the wiki website. While they're there, I can't really repost them. That wouldn't be right. But the OpenSees Pi ones, which are just a conversion, they're not perfect because I wrote a converter that converts the two, so it's not always perfect. But they're a great place to start with all these examples. And what I've done is I've made a series of videos on my YouTube channel starting from example 1 all the way to about example 5, and then I got distracted and I stopped. But I think it's really useful to see those videos. And really, I walk through all these different examples on getting started with OpenSees. There's other examples on the wiki as well. There's even examples with parameter studies, lots of resources there on the wiki that, you know, different users have done. Be careful with these because sometimes it may not be consistent with the latest version, but remember the point of these is to learn and gain understanding. It's not just to copy somebody else's script. And that's what's neat about this workshop that you guys have organized. It's a great way to, you know, have two-way discussions versus looking at old scripts. So I'm excited about it. There's a lot of developer resources as well if you go to the wiki. And again, Michael Scott has done some videos on compiling OpenSees on Visual Studios, and he's working on some other videos for developers. So there's a lot of exciting things going on there. As I said already, there's a command manual in the wiki, and there's the Python. The wiki one has figures, so open up both on your screen. And as I said, and you'll see that the difference is literally just in formatting. They were very careful to keep things in order. There's also forums everywhere these days. The main one is the OpenSees forum on the OpenSees website. I mean, there's 32,000 posts with 10,000 topics. So I would start right there because I bet your question has already been asked and it's already gotten 17 different answers. So go down here, there's things on OpenSees itself. Even the OpenSees Pi, which is relatively new, is quite popular already. And as you can see, you have responses from the developers as well as other users. So it's really a great community there. And this is managed by Dr. Gunai, who's going to give you the presentation. And so he has a lot of insight from a lot of different users and perspective on OpenSees. The Facebook group I've already mentioned. It's kind of cool. It's a place that I visit every day. I try to answer when I can. Sometimes the questions get complicated and they require more than a simple answer. And I wish I had more resources to be able to do this. I'm not getting paid to work on OpenSees, so I'm just trying to do what I think is appropriate and I can do in my limited time. The OpenSees support group is another great resource. Pavan Chigullapalli, he is a student in New Zealand. He and his group have organized these bi-weekly seminars that they actually hold through Zoom. So anybody can come in and they're great presentations. I presented a few weeks ago, Professor Scott presented, and different people are presenting. He's got something on geotech coming up. So I recommend, again, I put a link on my website where you can fill out this Google form so you can get on his email list. And it's great because you can actually speak to, and if you actually can attend the live sessions, it's a great resource to speak to developers themselves. With New Zealand, and I know everybody's all over the world right now, with New Zealand, just make sure you've got the right time and date, because for me, they're 4 hours behind, but 1 day ahead. So when workshops are on Saturdays for him, or I think he holds them on Fridays, it's actually a Thursday for me. But as you guys have learned from this workshop, time is irrelevant these days. And then there's a lot of other ventures out there. There's GID for OpenSees. There's a converter. So on the website itself, the peer website, there's a link for OpenSees Navigator, which is very popular, but I think it's relatively old. There's on the OpenSees website, there's those, but I put in links to others. There's ASDA Soft, which is what Dr. Petraka is going to talk about on Sunday at your workshop, but there's a lot of other software. There's BuildX is by a professor. Oh, I can't remember his name, but he's up in Britain, but I think he's Greek. And Next FEM is another venture in Italy. Dr. Christian, I can never say his last name, he's going to be presenting on walls. He's actually written a converter from ETABS to OpenSees. So and these are just a few that I know about. But there's a lot of other ventures out there. Some are free, some are pay. I know it's hard as students to pay for certain things, but to keep these programs continuous and not just, oh, spend a little bit of time here and there, we need to make a commitment to what's going on and what's being developed. The other opportunity or the other resource out there is the high performance computing at DesignSafe. So here's a link to it. You can run OpenSees on the fastest supercomputers in the world, but I don't know who has access to it. I've been in the US, I do, but I'll let you look that one up. The Sim Center is Frank McKenna's latest venture. It's kind of neat because to me, it's like OpenSees on steroids, because he's taking his idea, because Frank McKenna developed OpenSees. He's taking his idea of object-oriented programming to object-oriented simulation. Remember, I told you at the very beginning, OpenSees is just a tool. And so in the Sim Center, OpenSees is one of the tools, but then they also bring in OpenSHA, the GEM models, and it's really looking at simulation of everything associated with an earthquake, but I think they're going multi-hazard as well as windstorms and tsunamis. And so really bringing different tools in where OpenSees is it's not just one, because of course is the best one, but keeping in mind how you can integrate OpenSees with other software as well and other parts of your programming, of your simulation. And then, as I've already mentioned, Google. Put 3 keywords. Maybe if you were very specific, you can put 10. And I always find that I put in one thing and then it takes me in different places, and I always have I end up going down this rabbit hole with Google itself. It's kind of neat because you can see, the first hit, and I don't know if I did any order in these searches, but just to show you, it sends you to the Wikipedia pages. There's also the OpenSees Pi. Here's STKO, right? This is the software from ASDA Soft. So that pops up in Google and you're like, oh, what is this? And you click on it. There's simple slide shares from the old days from Frank, and there's things on OpenSees for Fire. Click on that. Maybe you don't know anything about Fire, but there's things that you can learn about OpenSees and different applications of OpenSees. So spend a little bit of time, when you're idle, instead of going through your TikToks, go through your OpenSees, Google OpenSees, and see where it takes you. Same thing with YouTube. So it's kind of cool because on the top left, I show you, I did a search by date. So the latest videos on OpenSees. And so it's kind of cool because this is the OpenSees support group where Professor Scott talked about how to add a uniaxial material in OpenSees. There's me. I did a video on applying wind loads because that wasn't in the examples manual. So I thought it was kind of something to put in there. And then something on particle finite element and modeling scouring in OpenSees. This is actually a really interesting topic. It's a geotechnical issue, but you can bring it into it really affects your structural behavior. If you then look at the most popular videos, I mean, look at this. This is from Discovering OpenSees, and I don't, from 9 years ago, and it's received 30,000 views. 17,000 is the next one. That's a big gap. And there's even a really good video done by Professor Filippo on an introduction to nonlinear analysis from 7 years ago. So all these different topics and applications of OpenSees, where you're not just learning about OpenSees, you're learning about numerical simulation, which is really the goal here. We're not getting your PhD on learning OpenSees, you're getting your PhD on using OpenSees. And so it's great to have this workshop because it accelerates the learning curve. And there's a lot of resources on how to take that one step beyond. I'm gonna, at this point, I give a plug to, of course, my website and what I'm trying to do. In May, I reduced my time at the university to dedicate, and this was planned way before COVID, so it's kind of funny how it all, but I wanted to go back to OpenSees and try to bring, because there's just so many different things going on, to kind of bring the energy back and finish off the story that I was trying to tell. I have so many years experience in teaching OpenSees and in using OpenSees. So that's what I'm trying to do right now. And I'm mainly working with engineering firms, but with a lot of students as well through just one-on-ones and different types of sessions that we offer. So I wanted to, here's my plug for what I do. I do a lot of consulting also in ground motion, which is really where my current consulting is focused on. I've developed the Silvia's Brainery, which is an online academy where I put in course bits and the main course on mastering OpenSees. This is all just pre-recorded videos on the fundamentals of OpenSees. I don't focus so much on the commands, but understanding what the framework of OpenSees is. I recommend it because it really answers a lot of questions and it's gotten some really good reviews. So that's where I always send people to learn those things so that you can understand better why you're doing what you have. And I've got a few different contributors now. I'm actually working on bringing in Professor Panagiotou. I like how you guys said that, into the Brainery. I've got someone who actually is taught a course on Perform. And so we're just trying to bring in a lot of educational videos out there. There's also some training that we do, and I think I have a better slide of this. So this is from the courses. There's Mastering OpenSees, there's Mastering Perform, but then there's this little thing that's called OpenSees Cafe. This is a weekly, we meet on Friday mornings, and I know a lot of people can't make it because of the time zone, but we meet weekly to discuss questions that different people have on modeling. Not so much, there's some basic users, and they literally just are learning so much by hearing people talking about the different things that we do. But it's almost like a group of researchers and graduate students bringing in, questions. We bring up topics. Somebody's having issues with modeling. One of our participants, he's actually developing a joint element in OpenSees. So it's just, and one person is a software developer. So it really just, it's a lot of energy in this meetings. Professor Michael Scott and I are there to guide the discussions. We were supposed to alternate, but we're having so much fun. We both try to make every one of them. And then there's additional courses there. There's also, here's the different instructors that we have. Hytham joined us in about 4 months ago because of the work that he had done with Perform. I really wanted to bring knowledge out there on all the different topics. We offer training. I get a lot of one-on-one trainings sessions. A lot of students are just getting started or having challenges with what they're doing. So they'll just sign up for an hour or two to meet with me or with Professor Scott if it's on development. And we're really trying to get you through that little hump. Right now, we're also training different companies on OpenSees. And as I mentioned, there's also the OpenSees Cafe. My YouTube channel, I hit 1,000 subscribers. There's no money in YouTube. I wish it could be financially sustainable, but it's not, because then I could quit my day job and dedicate more time to this. But it's a great resource. I put a lot of videos out there. There's plenty of free videos on my channel, especially like the examples manuals and things that I think it should just be out there for free. So there's a lot of videos just on my channel itself. And that's pretty much the summary of what I'm trying to do, just, you know, building this community and getting people engaged. It's not just one way, oh, here's my videos. And that was the problem that I was having with YouTube. They're just videos, and maybe sometimes you'll get a comment here or there. I'm really trying to get a conversation going with the community and being able to go beyond OpenSees as well. And then the products I've developed, just like everybody else, I've developed my own OpenSees user interface that I called EEAT. And what I want to do is I'm going to give you some highlights and just kind of end the presentation with a cute little video. And it's got cool music to it. I don't know if you guys allow questions or if there's discussion, but when the video is done, I'll be back for questions. So here's a little summary of what EEAT is. What I wanted to do is I want to develop a user interface that's just not just graphical, because I think there's a lot of power to being able to program your user input. So there's things like this where I have all these nice, and this is all Tickle TK. So TK is a great library that Tickle has for doing user interfaces. And I wanted to show you this, not just because how wonderful and awesome the one that I have developed is, but this is something that you can do yourselves. If you want to, you know, you can develop your own little targeted tool for what you're doing. Pull down menus and things like that are great widgets in TK that reduce user error for the input. And then, excuse me, I'm going to sneeze. No, I didn't sneeze. Okay, whew. Now you know it was live. What I have also is everything can also be done in a script. So the graphical user interface is great to get things started, to run some testing of your materials and your models. But then when you need to run a lot of analyses and write a lot of variability in your input, you can always go back to the Tickle interface. I'm working on converting this also to Python, of course. There's a lot of, you know, really live interactive in building your model. Of course, the trick is the visualization of the response. So I try to do, it drives me crazy to draw the full element in certain colors, because this should only really be done at the integration points where I know what the actual values are, but this is just my own little pet peeve. I've implemented things. I'm doing fiber section analysis from your structure itself. So it's kind of neat. And here's a big link that you have up on the right-hand side anyways, if anybody wants to just not have to type in Silvia's Brainery. The apostrophe doesn't belong there, but it's a way to keep it all together. I'm going to switch over to this little video. Let's try that.
Now we got sound as well. Good.
Oh, excellent. So it's great to testing materials, which is what I'm showing here.